Okay, is it visible?
Yes, ma'am.
Dear participants, please respond. Is it visible?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am. No, it is.
Is it changing? Slides
Mm,
are changing or not?
No, ma'am.
Not
Please
changing.
respond.
No, it's not changing.
Not changing. Okay. Is it visible now?
Yes, ma'am.
Now let me try to change with full screen. Is it changing now?
Yes, ma'am.
Yes, ma'am. It
Yes,
is.
yes.
Okay. So already Mr. Dashankar has given my introduction to you. I'm not going to in details now. I have checked the participants' details where we have agricultural participants from agricultural statistic background and political science background and all these things. I think all of you require to construct index like socioeconomic index or for agricultural sector like agricultural production, agricultural field-based index like this. So for that, we have different methodologies available to us, and that all methodologies actually belongs to the category of multivariate method. So what we need for that one, I'm just giving you a simple introduction. Don't worry about this covariance and all these things. I shall discuss each and everything in very simple way. So what we need a big data set. So if you have a small data set, you cannot use any one of these methods for construction of index. Any kind of index, even in commerce, you need to develop, say, for bank transaction index or diversity index, like that kind of index, based on the primary data you have collected, and you need to construct that kind of indices. So what we need initial stage is the big data, big data set. Without having a big data set, you cannot construct such index because you are going to lose some of the information. So in the process of constructing of indices, so we need big data set. Then you need to understand one, I mean, variance covariance concept. Variance is the square root of the variance is the standard deviation. So you don't have to worry about the standard deviation. Variance, covariance concept you need. Covariance is the correlation. That is how these two variables are related. So multivariate analysis has different forms, you know. So one of them is multiple regression. So this covariance analysis actually enable us to understand the interrelationship between the two or more variables. Now, covariance means two variables. So if we have three variables, we have to combine them 2 by 2. So just check the third point here, fourth point here, the variance covariance matrix. What we have considered three variables, x, y, z. Now, when we are calculating this variance and covariance, what we are doing, we are just combining 2 by 2 variables. So we are considering a x relation with x, then x relation with y, then x relation with z, then these three combination, again y relation with y, y relation with x, y relation with z. So this is the matrix we have used here, is the matrix, and this matrix, this is the diagonal times, that is covariance of x, x, covariance of y, y, covariance of z, z, nothing but the variance. and the square root of that is the standard deviation. So these diagonal terms are the variance, and the off-diagonal terms are the correlation, interconnection between the two variables. Is it clear, dear participants? Please respond. Is it clear?
Yes, ma'am.
This,
Yes, ma'am.
this variance covariance idea, almost all of you from your background is there. You have, I know that from your background, I know that. But if you have any problem with variance covariance concept, or you may forget that one, you may not work with it for a long time, it's quite natural, you may forget. So feel free to say that one, ma'am, you have to discuss it little bit more. So these diagonal terms are our variance and off-diagonal terms are our covariance. When we are conducting this kind of multivariate analysis, where multiple regression is also a part, we will discuss this later on, these off-diagonal terms are most important because what I said, the interconnection between the two variables. If you consider y as a dependent variable, x and z as independent variables, so how these independent variables are correlated with each other and how this dependent variable is correlated with the independent variable, it is most important for our purpose or for purpose of any kind of econometric analysis. Okay, so the variance terms are of course important, that diagonal terms are of course important, but that off-diagonal terms are of most importance. So these diagonal terms are our covariance and the off-diagonal terms are our covariance. Now, if we have n data set, that is we have considered 3 variables. If we have this kind of n variables, then what will be the number of covariance values? That is how many off-diagonal terms we will get, factorial n by factorial n minus 2 into 2. Factorial n minus 2 into 2. You can consider from here also. We have 3 variables. So it will be factorial 3 by factorial 3 minus 1 into 2. By that way, how much we get? That is, it is 6. So add 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. So 6 of diagonal terms we will get. And what I said, that this covariance term is most important because what it is revealing the relationship between the dependent variable and the independent variable and the interconnection simultaneously. It is also disclosing the interconnection between the independent variables. Now, I have written this in the matrix format. So, if it is in the matrix format, then correspondingly, 2 important concepts are eigenvalues and eigenvectors. Very simple way. You don't have to remember this. You know the commands nowadays, the statistical packages are available to us, and giving the commands, it will give you the answer. I shall describe practically that how we can get the results and how we can interpret it. So don't worry about that. If you miss something within this discussion and you are not able to understand clearly any concept, so don't worry about that. We will discuss it again and again. And anytime you can stop me and ask me question. So next important concept related to this are the eigenvalues and eigenvectors. Okay, so what is eigenvalues? You know, in Bookistan, what it is saying that eigenvalues are the spatial set of scalars associated with the system of linear equations. So I said that it is used for regression analysis, linear regression, non-linear, not non-linear one. So linear regression. So linear equations. It is used, mostly used in matrix equations. So what I said, this is this variance covariance is written in the matrix format. So it is used for the matrix equations. It is mostly used in the matrix equation. eigen, the term eigen came from the German word, and this eigen means what? That it is proper or characteristic. Proper or characteristic. So eigenvalues reveals the proper or characteristics of that linear equation. Proper or characteristics of that linear equation. So for any equation, the roots are the characteristics. So these term eigenvalue can be termed as the characteristic value or characteristic root or proper value or the latent roots. So these names, useful in different situation, in different purposes. When we use, what are the purpose of our use? Based on that, this eigenvalues changes its name. So what are the different names associated with the eigenvalue? Characteristics value, characteristics root, proper values, and the latent roots. Now, in simple terms, what do we mean by eigenvalue? The basic equation is Ax equal to lambda x, a linear equation. Ax equal to lambda x. The number or the scalar value lambda here is the eigenvalue of A. So this lambda is the eigenvalue of A. This lambda is the eigenvalue of A. Now, eigenvectors are the non-zero vectors. These eigenvectors are the non-zero vectors. And in mathematics, an eigenvector corresponds to the real non-zero eigenvalues which point in the direction stretched by that value. Eigenvectors are the non-zero vectors that do not change the direction. So if the direction, if the movement is here, this is the dependent, this is the independent. So eigenvectors will not consider this part as the dependent, this part as the independent. It will move in the same direction as in the initial phase. So eigenvectors are the non-zero vectors, and it will not change the direction. So in simple terms, if we are considering n by n, that is a square matrix. Here it is a square matrix. Here the number of rows and number of columns are same. It is 3 by 3. So it is a square matrix. So we are also considering here A is a square matrix, n by n matrix, and lambda is an eigenvalue of matrix A. Then X, a non-zero vector, is called the eigenvector if it satisfies the following expression. Here lies the beauty. Here lies the beauty. So we have started from here, Ax equal to lambda x, and eigenvalues are saying that whatever we have assumed the relationship, that is the relationship is flowing from Ax direction to lambda x direction, is true, because we have it is saying that if A is a matrix of n by n, that is a square matrix, and lambda is eigenvalue, then there is a non-zero vector which actually satisfies the relation Ax equal to lambda x. So eigenvalue as well as eigenvectors together in the eigenspace enable us to identify the basic linear equation. So eigenvalues, eigenvector together in the eigenspace enable us to identify the basic linear equation. Now, so far, is there any problem to any participants? Please respond. Is it comfortable?
Yes, sir.
Okay, so let me proceed. So we are considering now the multivariate analysis. Now, what is multivariate analysis? Multivariate analysis is a branch of statistical analysis which is concerned with investigating a relationship between the set of different variables. Now, those who have a regression analysis idea, they also say that we do the same thing in case of multiple regression. multiple regression is a part of multivariate analysis. If we consider women, women, they have just gone. So if we consider women, so woman is a big set and Indian woman is a subset. So multivariate analysis is a big set and multiple regression is a subset. So many things are included in the multivariate analysis, and one of them is the multiple regression. We will come to that one also. So what is multivariate analysis? Multivariate analysis is another statistical tool, but it has so many shapes, so many applications. So what it does, it helps in investigating the relationship between state of different variables. Here the variables, the dependent as well independent variables are big, so we represent them in the form of matrix. Now it has two main characteristics. What are they? First is that multivariate analysis is concerned with the set of n individual, each of which bears the value of p different variables. So what does it mean? That the essential characteristics of the analysis is the multiplicity of p variables, not in size of the set containing n individuals. So it actually p different variables. It is not the same thing. That is, we are not considering wealth as well as income while determining the consumption. So, but suppose we need wealth as well as income. So they are proxy for the consumption. Consumption depends on income as well as consumption depends on wealth. So you may not have income flow, current flow of income, but you belong to a rich family and you have enough wealth to support your lavish lifestyle. That you can do. So that kind of thing. So if the relationship between we are considering wealth as well as income. Now keep that in mind. We are considering wealth and income. So there may be some correlation between wealth and income. So we are not considering income and income. We are considering wealth, income, or say family size for consumption expenditure of we are conducting our family survey where we are doing a survey of consumption expenditures for different households. And what we are considering for that, the income of the family, the wealth of the family, the composition of the family, whether yes, the composition of the family, like this kind of variables. We are not considering income, then again we are considering income, then we are considering income cube, not like that. We are considering different variables, and we are not considering only a single individual. We can conduct that kind of study also, single household, and for different time periods. That will be our time series data. But in case of indexing or this kind of multivariate analysis is mostly applicable in case of cross-sectional data. So for a particular point of time, we are considering the individuals. We are considering different households for a particular point of time. The second important characteristic is that the variables are dependent among themselves, so that we cannot split off one or more variables from the other and consider it by itself. All the variables are to be considered together. This point is important for our purpose. Two characteristics. If we can separate the impact of the independent variable on the dependent variable, we have different type of multivariate analysis. If you cannot separate the impact of the independent variable on the dependent variable, we have different branch of multivariate analysis. The question is that whether we can separate them or we cannot separate them. In one case, we separate them and we have another analysis. In another case, we cannot separate them and we have another type of multivariate analysis. Now, at the beginning, I said that sometimes multivariate analysis is misconceptualized as multiple regression analysis. Multiple regression analysis is a part of multivariate analysis. However, multivariate analysis is more vast, more wider than the multiple regression analysis. Multiple regression may be divided. It is not multivariate analysis. Multivariate analysis subdivided into several parts, and one of them is the relationship between independent variable and the dependent variable. The relationship between the independent variable and the dependent variable. For example, suppose we are considering, as I said, that we were considering that consumption expenditure of any household depends on what? Income, wealth, then family composition, then number of working person in the income earning person in the number of people in the age group 15 to 59 who are employed. So these kind of things we can consider. So this where consumption expenditure is the dependent variable, it is on the left hand side, and rest of the variables are on the right hand side, which are called as the independent variables. So multivariate analysis concerned with the relationship with dependent variable and independent variable. Now sometimes what happens, the independent variables are interconnected, that is correlated. As I said, correlation, so covariance. So this covariance between the independent variables, I mentioned X and Z as independent variables. So this covariance of Xz is too high. Covariance of Xz is too high. So if so, we cannot separate the impact of Z on Y and X on Y independently. So we cannot have the independent effect of Z on Y and X on Y. This is one situation. And in another situation, we can separate them. So if the independent variables are interdependent, then we cannot conduct multiple regression analysis. That will result in multicollinearity problem. So if we have a multicollinearity problem, we cannot use multiple regression analysis. However, we can use multivariate analysis because, as I mentioned, multiple regression analysis is a part of multivariate analysis, and multivariate analysis involves different types of tools which allows us, even under such kind of interdependence among the independent variables, to deal with it. So multivariate analysis is much more wider than the multiple regression analysis. And if these independent variables are not interconnected, we can use multiple regression analysis. That is, we can regress Y on X and Z. And if X and Z are correlated, that is, we have a multicollinearity problem, it will give misleading result. So in such a situation, what we need to do? We have to drop one variable. So instead of multiple regression, in this case, it will be simple because we have only two independent variables. So we have to drop that variable. But multivariate analysis involves different tools which allows us, even in this situation, we are not dropping the variable, we can continue. Okay. Now, multivariate analysis has wide application. In case of agriculture, it has application. In case of economics, it has application. In case of education, it has application. Physics, it has application. It has wide application. Now, let me go to the all picture. That is, this is the multivariate analysis method. Let me go back to the earlier slide. What I said here, that the variables are interconnected and the variables are dependent, independent. So we can separate the variables as dependent variable, independent variable, and in another case, we cannot separate the variables in dependent and independent variable, and the variables are interconnected. So one is dependent-independent relation, another is interdependence method. Clear? Is it clear, participants? Please respond. Is it clear?
Yes, ma'am.
Yes, ma'am.
Okay. So we have dependence method and independence method. Okay. So one variable. Now and we have several variables. So if it is metric, that is, it is a scalar, then we have multiple regression or multiple discriminant analysis. Yeah, if we have several variables, then are they metric? If it is yes, then we have if it is metric, if the answer is yes, we have multiple regression analysis. If it is no, that is they are not scalar one, that is they are not measurable entity. If they are measurable entity, that is variable, metric means variable. So we have attribute also. So if it is metric, if answer is yes, we have multiple regression. If answer is no, we have multiple discriminant analysis. Then we have several variables. Again, the question is, are they metric? If yes, we have multivariate analysis of variance, that is MANOVA. It is called MANOVA. And if they are they metric, if the answer is no, then we have canonical analysis. Canonical correlation is also a very famous method. Canonical analysis. Now, in case of interdependence, again the question came, are they metric or no? So if are they metric and answer is yes, then we have factor analysis. Among them we have principal component analysis, cluster analysis, then metric, multi-dimensional scaling. MDS stand here, multi-dimensional scaling. Then if it is non-metric, if your answer is say metric and non-metric, so if it is non-metric, then we have non-metric multi-dimensional scaling, and last one latent scaling, latent structure analysis. So if inputs are metric, then we have factor analysis. Among them, principal component analysis is one, which we are going to discuss in details. Other than this, we have cluster analysis, then metric, multidimensional scaling. And if it is non-metric, that is no. If the answer is no, then we have non-metric multidimensional scaling and latent structure analysis. This latent structure analysis, one of them multidimensional scaling, one of them is the multiple correspondence analysis, which we discussed in today's class. So this is all about the multivariate analysis. It involves so many things. Multivariate analysis involves so many things. We sometimes just mislead ourselves that this multivariate analysis is synonymous to multiple regression. No. Now you know that this multiple regression only a small subset of multivariate method. Multivariate method actually involves a big branch of statistical proof. Okay, so let me discuss this multivariate analysis little bit more details, in more detail. So what is next? That so what? Let me just summarize what we discussed so far. That we came to know about variance, covariance, and we came to know about the importance of the covariance analysis, And we also understand what is dependence method and interdependence method. This, this interdependence is most important for indexing purpose. When you want to index, that this interdependence is most important. Or when you want to reduce the scale, scale reduction is also possible by this method. Scale reduction means what I said, that I consider income as well as wealth, income and wealth, but both of them are fulfilling the same purpose. So we need to drop if we want to use multiple regression. But wealth is also very important factor in determining the consumption. We have so many examples where they are not earning, but they are enjoying a very vibrant life, very lavish life. You whatever name coming to your mind, you can ask yourself. Such kind of person are very prominent in our present life, in our daily life. So we cannot do the multiple regression. In that case, we have this factor analysis. If we want to perform indexing or want to reduce the scale, then we have to have this interdependence method. So if there is no multicollinearity, we can go for multiple regression. If there exists multicollinearity, we can conduct factor analysis or principal component analysis. Is it clear? Please respond. Is it clear?
Yes, ma'am. Yes.
Okay. So next we are going to consider a multivariate analysis. So multivariate analysis, in analyzing the survey data, most survey analysts typically use straightforwardly this statistical approach, that is our multivariate analysis. And it is very common in analyzing one-way, two-way, or multi-way tables. That is, we can use multiple variables for them. And graphical displays of such analysis is also by chart lines we can present that in day-to-day life we use statistical tools for analyzing the survey data. We use graphs, bar chart, line graph, etc. Multivariate method, deal with simultaneously the treatment of the several variables. So we can use these variables for different purposes. And these variables can be used for various purposes, such like as an explanatory tool with which to investigate the patterns of data. As I said, that you can reduce the dimension of the data while surveying and collecting data through interview method, personal interview. You go with the questionnaire, and while preparing the questionnaire, you may have in your mind that all these questions are important. Then you find the data set becomes very big. That is, your variable is very big. Then we use this multivariate analysis, particularly the interdependence method, to reduce the scale, where we can extract some of the variables which are most important for our purpose, and rest of the variables we can drop because they are not so important. So that way, this multivariate analysis helped us. Secondly, it tells us the natural groupings of population for further analysis. That is what the cluster analysis does. We clustered the population into several groups for the purpose of our data collection. So that is also a part of multivariate analysis. We clustered the population into several groups. And I have already discussed that the dimension of the number of variables we can also reduce by using the multivariate analysis. It is an advanced technique. multivariate approach is an advanced technique. Multivariate approach are used as a valuable descriptive procedure during the initial stages of data exploration and in index construction. Data exploration, what I said, that by using this interdependent method, interdependent tool, we can reduce the dimension of the variable, as well as we don't suppose we don't want to reduce that dimensions, and the variables are correlated. So we cannot do a regression analysis, that is not possible. So what we can do, we can find out the weights of each of the variables, and then we can construct an index. We can construct an index for that. So multivariate approach is a valuable procedure to explore the data in the initial stage, where we can conduct the data dimension reduction, or we can use it for index construction. The techniques should therefore be used after careful examination. The data structure, the strata, substrata, the population should be defined properly, the population should be clustered properly, data should be collected in such a way so it will be very informative as well as extensive, exhaustive. That is, we have if we want to construct a socioeconomic index, then the data should be representative. Otherwise, whatever conclusion you are going to draw based on the multivariate analysis, that will be biased. So that will not give you a general information or a general conclusion. So for having a general conclusion, the data must be very carefully conducted. The survey must be conducted very carefully. Before conducting a survey, you have to have a pilot survey, and then you apply the multivariate analysis, and then you go back for the appropriate data set. You may have a big questionnaire. After application of the multivariate analysis, you first reduce the dimension, and as well as you just divide the entire study area into strata, substrata, and to fulfill the main survey objectives, and then you conduct the survey. And even within the substrata, in some cases, we have to have some sample analysis, and for that we need to conduct the multivariate analysis. That is what I said, that before going to the main survey, we have to do pilot survey, not a single time, but several times, because you are going to conclude about based on the primary survey. And if you want to, a significant number of participants are pursuing their PhD, so you need publication. So for good publication, based on the primary survey, you have to prove that you have used this multivariate analysis several times for dividing the study area into substrata, for reducing the dimension of the data, so that we can reach to the main survey objective efficiently. Clear? Finally, when we have appropriate data set, we can use the data, we can finally conduct the multivariate analysis, and can conclude about the weights, and can construct the index with confidence. Even after constructing index, there are certain statistical tools by which we can test the validity of such index. So before conducting this, we have to be very careful about this track. Now, in case of strata, another important factor. when we are doing the sample survey, we can give weight to the samples. What I said that while doing you are dividing your study area, your sample area into different strata. Now, all the strata may not be equally important. So we can give weight to the survey area. Some of the survey area may be more important, particularly in agricultural sector, that some of the areas are more fertile compared to the others. So if you are considering the productivity or production, then you have to give some weights to this area and you have to give some weights to the other areas so that you can separate these areas. So you are considering both the less fertile and more fertile area. You cannot take data rawly from here. So some of the statistical packages itself inbuilt have some given weights. Like in case of strata, there is a command await, AWEIGST, await command, which actually help you giving the weights to different substrata, and these weights can be used as a lambda factor that we use now, AX equal to lambda, so some sort of eigenvalues this give. Although eigenvalues idea are different, but we say that this X can be used as a lambda factor. So even the survey areas, when we are dividing the survey areas into different groups, this multivariate technique is helpful in choosing the survey area or giving weights to a particular survey area. So the basic thing under the multivariate method in survey investigation is simplification, reducing a large and possibly complex body of data to a few meaningful survey summary measures or identifying key features and any interesting pattern in the data. So what in the kernel of the story, in summary, what we can say that the complicated survey process can be simplified by using the multivariate analysis. Complicated survey process can be simplified by using the multivariate analysis. Secondly, we have a big set of data and we can reduce them into some few meaningful summary measures to identify the key features and to identify or to investigate the pattern in the data. Such method can help in generating hypotheses of our interest, and again researcher can test this hypothesis. So multivariate analysis not only helping in identifying the appropriate survey area, but also help in data collection, appropriate procedure in data collection. Even after collecting data, it helps in reducing the data, in simplifying the data to a few meaningful summary measures, and finally, it helps to explore further the interesting pattern of the data. And this and ultimately, it helps the researcher to form the hypothesis and to test it. So it can help you the completing your research. It helps you to complete your research. Okay. Next is multivariate method. The basic thing I have already discussed these issues. The basic thing underlying the use of multivariate method is survey investigation is simplification. So our objective here is to simplify. Our objective here is to simplify the data. We have to simplify our complicated survey procedure. We have to simplify our big data set into a few meaningful data sets. So simplification is done by multivariate method. And often what we do that it helps in generating the hypothesis as well as based on the researcher's interest as well as as well as to test the hypothesis. Next important thing is that when we are doing this kind of survey, we have some underlying assumption about the distribution of the variable as well as the distribution of the error term. So we are not going to discuss the distribution of the error term. The distribution of the variable is very important. When you are going to conduct the factor analysis or principal component analysis, this distribution part is very important. So some of the approaches are distribution tree. Today we will discuss two approaches. One is based on distribution, another is distribution tree. So some of the approaches are distribution tree, and this kind of method are also a part of multivariate analysis. We have data matrix, which is the starting point is that our data matrix, that is whole set of data, whatever we are collected, represented in terms of rows and columns. So variables and the information represented, that is sample units, are represented by rows and columns represent the variables. Keep that in mind. Sample units are represented by rows and variable columns representing the variables. These are the different techniques of multivariate analysis. The first one is the descriptive multivariate method, data exploration, identifying patterns and relationships, then principal component analysis, dimension reduction by forming new variables, the principal component as linear combinations of the variables in the multivariate state, then then cluster analysis, identification of natural groupings among cases and variables. I said that your total sample area you can cluster. Clustering technique is a wide application of the clustering technique. Suppose you are facing problem in collecting data, then you apply cluster. And earlier you are considering household as a single unit. Now you consider each member of the household as a single unit. So if a family has 5 members, you have 5 samples. That is a clustering process. So based on the your objective, you can apply the cluster. Cluster can widen the data. Cluster can condense your data, can reduce your data. Then it is factor analysis, modeling and correlation structure among variables in multivariate response set by relating them to a set of common factors. Then multivariate analysis of variance. It is MANOVA. MANOVA has its own wide application. Then discriminant analysis, determining functions that enables 2 or more groups of individuals to be separated. Another important factor is correspondence analysis. First, we learn about the principal component analysis. This correspondence analysis is similar to principal component analysis, but one major difference between them is that it is applicable to the categorical rather than continuous variable. So if you have categorical variable, you cannot apply principal component analysis. However, you can apply correspondence analysis, canonical correlation analysis, and multidimensional scaling. These two things I'm not discussing in details. We will concentrate only 2 things. One is principal component analysis. This will help you reduction in data as well as finding weights for each variable for index construction. Then correspondence analysis. It will also help you finding values, finding weights of the different variables, where no other analysis, particularly principal component analysis, applicable. Up to this, any question from anyone sent? Please respond, participants. Hello.
Good evening, ma'am.
Yes,
Ma'am, am I audible?
yes, yes.
Ma'am, actually, I wanted to ask you something. I'm not from statistical background, and my question may sound a bit weird to you also.
No, no,
But
no.
as you are trying to explain it in very simple terms, and I'm trying to learn it, I just wanted to ask you that time and again you are saying this, that this kind of analysis will actually help us to draw when we will analyze our data, to drop out the less significant areas, and so that the more significant areas could be concentrated, and easily the result could be obtained. I just wanted to know that is multivariate analysis can lead to any kind of biasness in doing that? The question just came in my mind, but as I said that
No, no, no.
uh,
Very good question. You were saying it was just not at all. It's a very good question. You know, in order to avoid biasness, when we are considering, suppose we are considering study area, for example, suppose we are considering some areas of Assam and we want to compare them. Even in Assam, even in West Bengal, we are considering different districts. Now, these districts have different population structure, have these districts have different income groups, different food habits also. So when you are considering them all together, that may result bias. So if you are giving
sorry ma'am, I can't hear you.
ম্যাম মিউট হয়ে গেছে। ম্যাম ঠিক আছে, মিউট হয়ে গেছেন। মিউটটা
এবার
আনমিউট।
শোনা যাচ্ছে?
হ্যাঁ এবার আসছে।
আচ্ছা,
হ্যাঁ ম্যাম, শোনা যাচ্ছে।
আচ্ছা। Is it changing? The slides is changing?
Yes ma'am, they are changing.
Okay, thank you. So, whoever asked the question, that was very interesting. You know, if we are considering, suppose different districts of West Bengal is your study area, and you are collecting data from different districts of West Bengal. But even if they have a common characteristics that they are the districts of West Bengal, these districts of West Bengal have different population composition. These districts of West Bengal have different food habits. So if you are considering health, suppose religion has a strong implication on food habits, and food habits has strong implication on health. So if you are conducting any survey for health, so religion are different. So you can give some weights to the areas, and you can, by using the multivariate analysis and await the command using strata, you can identify which district have to be used for your purpose based on some of your characteristics that you want to have. You want to conduct a survey on health, suppose health of women, postnatal health status of women. So for that, religion is important, population composition is important. This kind of information you can use as to choose the study area. If you conduct this before choosing the study area and then you go for the survey, the biases will be less. However, you cannot eliminate the bias fully. You can eliminate the bias fully only by conducting, taking the whole population. If you are conducting a survey based on drawing a conclusion based on sample, then there will be some biases. But the beauty of sample survey, it itself will tell you the amount of bias. কতটা ভুল ও নিজেই বলে দেবে. It itself will tell you the amount of bias that you cannot have in case of population, and it is impossible to conduct a population survey. So
Exactly.
we always prefer to have sample survey as a part of and we, based on that we conclude. That is why the hypothesis testing we conduct. So this multivariate analysis will also help you to construct the hypothesis and to test it also. So by that way, multivariate analysis helps you reducing biases in every stage. So in the ultimately, your bias will be almost zero, but not equal to zero, almost zero in the limiting sense.
Okay, ma'am. Ma'am, thank you so much.
You are welcome. Any more question from anyone sent? So what I said, we will concentrate today only in case of principal component, that is we will consider the principal component analysis, one method of indexing or finding out the weights of the index. You know, indexing procedure are different. One of them is the preference index. Some of you are assistant professors, some of you are teaching in the school and teachers. So, and all of we are teachers. In near future, we will be. So, we cannot love all our students equally, although we have to, but we cannot. We are ourselves are biased. Some of students are our favorite one, like that. So, we are giving weights by ourselves based on the information. What kind of information? Based on their response in the class, based on their interaction with us, with their intelligent question, with their queries. So we give weights to them, and by that way we are some of them are favorite to them. So when we index them, the value of the index is higher for them, and that is why they are favorite. And some of them are value of the index is very low, so they are not very favorite, but of course our student, like that. So principal component analysis is used for two purposes. First one is the dimension reduction, that is we have a big set of questionnaire and then we apply principal component, and then we just exclude those questions which are not important, which are not at all important for us. So that is what I say, that conduct a pilot survey, then conduct a principal component analysis and get your answer. So that is. Another is that after that survey conducted, you have applied principal component, you have reduced the data, and then you want to construct an index. But before constructing the index, you have to check the multicollinearity. If there is higher multicollinearity, that is the variables are interconnected. We discussed that interconnected method and the dependent method. So if the variables are not interconnected, we cannot use principal component analysis. If the variables are interconnected, then only we can use the principal component analysis, and then we can apply and we find out the weights for the variables. Okay, and another one is the correspondence analysis. It has a particular name, that is one branch of correspondence analysis is the multiple correspondence analysis. I'm sure very few of you have some idea about it. Multiple correspondence analysis is the beautiful one, you know, for the completely for the categorical variable, rare one, completely for the categorical variable. In case of categorical variable, we are hopeless. We cannot use it, we cannot drop it, like religion. If Hindu 1, if Muslim 0, or vice versa. If Muslim 1, Hindu 0, like that kind of variable. Gender or sex, if female 1, male 0, that kind of variable. You cannot exclude them, you cannot do our indexing. So that is used for multiple correspondence analysis. Correspondence analysis is basically used for them. It's a multivariate statistical technique, but here we are not going to do a data reduction. We are just going to have a index. So indexing can be done by using principal component analysis, or by, in case of principal component analysis, you know, you can have preference index also. You can give according to your preference the weight. I said favorite student, you give some more weight to the, not in answer script, gives some ওই ছেলেটা একটু ভালো, the boy or the girl is much better than the other. We generally talk with our colleagues now, and about the good boy or good girl. And the conclusion is same from other colleagues also. So that boy or the girl, that student is good. So that kind of thing, you are giving some weights that good for that one or little bit less good. The comparison between the two. So this weight you can do according to your preference, but again it is very criticized on the ground that it largely involves the discretion of the researchers, and principal component analysis is a machine tool. It doesn't have such kind of emotion that he is good, he is bad, based on their number, based on their attendance, based on their response in the class. It is giving some weight, and so-called the good boy may become a moderator because of this principal component analysis. Am I clear to all of you?
Yes, ma'am.
Yes, ma'am.
Okay, so let us consider the principal component analysis. So what is principal component analysis? I can take class up to 7, isn't it? It is 6:05. 20 minutes more we will discuss it, and then we will go for the practical analysis. Okay, so the practical class, we can do it by using Strata. Okay, so principal component analysis, I have already discussed that it is identifying patterns in data and expressing the data in such a way as to highlight their similarities and differences. The other main advantages of PCA is that once we have found the pattern in the data, we can encompass the data, that is by reducing the number of dimensions without much loss of information. So we have a big questionnaire set, and by applying principal component analysis, we can fulfill our specified objectives without much loss of information. So what are the objectives when we are using the principal component analysis? First, to economize. The first one is to economize in the number of variates. This is the first one, in the form of linear combinations. So we convert them into a linear combination. Second is the identification of the principal components. So principal components are the linear combination of the existing variants. So new variates are called as principal components, and we can find the weights for indexing. So here is the principal components. X1, X2, XP were our variables. We have given some weights, and we get the principal components as a linear combination of our existing variables, and some facts we have to. These are the loading Aij, that these are known as loading of the principal components. And two important conditions of the principal components are: first, the principal components are orthogonal. Orthogonal means that the off-diagonal terms are not zero. Off-diagonal terms, that is, we consider the variance covariance matrix. I hope you remember sigma square equal to covariance of x, then covariance of xy. I said the diagonal terms are the variance and the off-diagonal terms are covariances. So their covariances are not zero, that is, covariance exists. So multipolarity problem very much exists. Then only we can use the principal component. And the beauty of the principal component, you know what is that? Is it clear? The first point, is it clear? I don't want to lose I don't want to simplify the lecture because this thing is very important. Principal components are orthogonal. So variance covariance matrix, that initially the covariances were there. That is, covariance of xz, covariance of xy were there. After calculating the principal component, we have only the diagonal terms. The off-diagonal terms will become 0. That is, covariances are 0. So there were initially the multicollinearity problem. After calculating the principal components, the multicollinearity problem vanishes. Is it clear? Initially, we have multicollinearity problem. The principal components, after calculating the principal components are not multicollinear. Variables were multicollinear, but principal components are not multicollinear. Is it clear? Participants, please respond. Is it
Yes,
clear?
ma'am.
Initially, variables were multicollinear. That is why we use PCA, and applying PCA, we got the principal components, that is PC1, PC2, PC3. PCP are not there. PC1, PC2, PCP are not multicollinear. So the off-diagonal terms now become 0. So we have only the variance. The covariances vanishes. Clear? The second point is also very important. This is the beauty of the principal component. The first component, that is PC1, describe the maximum variance. The rest of the variance describe PC2. And gradually the component describing the variances reduces. Suppose PC1 describes 60% variation in the variables. Then PC2 describes say 10%. So PC1 and PC2 together describe 70% variation in the variables. Then PC3 say 5%. So 75% are described by them. So rest of the variables, suppose you have 20 variables, so rest of the variables only describe 25%. So you can ignore them. You can consider only principal component 1, principal component 2, and principal component 3. So the principal component analysis allows us, to have principal component in such a way that first component describes the maximum variation in the data, the second component the next maximum variation, the third component the next third maximum variation, like this. And I have already discussed this issue. That we have to transform data to a new uncorrelated variates, which accounts as much of the variates as possible in decreasing order. So already that maximum possible variance is the first one, second one is the next maximum, third one is the next maximum, fourth one is the next maximum. So if we have 20 or 25 variables, we may extract it to 2 or 3 maximum principal components. Is it clear? Is it clear, participants? Hello?
Please respond.
Hello, is it clear?
Hello, ma'am, am I audible?
Yes.
Yes, ma'am, it is clear.
Okay. So I'm not going to in details, the basic problem, basic model, these are that. Here it is important that after calculating the principal component, the off-diagonal terms becomes 0, the off-diagonal terms. And in the initial stage, these off-diagonal terms are not 0. So this matrix becomes orthogonal. So it becomes a diagonal matrix having 0 covariance with principal component. Okay, so index construction, first we can have dimension index. Human development index is an example of the best method of dimension index, and it is also preference index, because all the dimension of human development index, education, then health, then standard of living, are equally weighted. That is 1/3 weight is given. So it's a preference indexing, and dimension is that actual value minus minimum value, maximum value minus minimum value. So we can use this one for construction of the dimension index. We have to have the standardization. Standardization procedure is that variable minus mean divided by standardization enables you to ensure that the data set is normal, because to apply principal component analysis, normal data set, that is data should be distributed as normal, variable should be, we have said now in multivariate analysis involve two types, can deal with two types of variables. Variables with specific assumption about the distribution of the variable and distribution free. So principal component analysis involves one assumption that the variable must be normally distributed. And statistics said normal approximation is good for n greater than equal to 30. So you have to have a big data set. Otherwise, it is not possible to satisfy the assumption of normality. And normality is the basic assumption for principal component analysis. So I said multivariate analysis involves two types of procedure. One is saying that distribution free, another is have specific type of distribution. Generally it is normal in many cases. So if it is not normal, you don't have to worry. You have to do the standardization. So what is the standardization procedure? Value minus mean by standard deviation. It will transform the variable into normalization. And then you can conduct the principal component analysis. So in index algorithm, what we can say, select variable, check normality. For principal component analysis, normality is necessary condition as well as sufficient condition. If yes, then run correlation. If they said correlated, perform PCA. Initially, we will get a non-standardized index. Then do the standardization. How can we do the standardization? This actual value minus minimum value divided by maximum value minus minimum value. This is the procedure of standardization in case of non-standardized index, what we obtained by using PCA. Okay. Now the correspondence analysis. I'm not going to in details, because if I go to in details of the correspondence analysis, I shall not be able to show you. It is already 6:70, and if we take 15 minutes for both, because LCA will be very interesting and very small one, but you will get interest on that. So based on the information provided in contingency table that we have several in kernel of the story, we have to find the weights of the variables. Now, if the variables are categorical in nature, that is, you have modalities categorical. That is, for example, suppose health, prenatal health. So whether the mother got 3 tetanus injection or not. So the answer is yes or no. So yes 1, no 0. So categorical term. Religion. Hindu 1, Muslim 0. So categorical term. Sex. Female 1, male 0. So that kind of. Whether whether mother is alphabetized or not literate or not, we are not asking. We are asking alphabetized or not. Yes 1 or no 0. Whether you have mobile or not. Yes 1, 0. You are not asking how many mobile you have. You are not asking how many bicycles you have. Suppose you are considering multidimensional poverty. In economics, multidimensional poverty is not so much new, because in 2007 to 11 we have that concept, and it is now increasing. Even in sustainable development goal, it is saying that poverty to be reduced, along with it multidimensional poverty to be reduced. The basic difference between poverty and multidimensional poverty is that income is a determinant of poverty, and income is not a determinant of poverty, multidimensional. Other than income, the poverty to be measured in terms of other than income. So durabilities, availability of durabilities, whether you have constructed toilet or not, whether you remain you have dirty cooking, whether you are using dirty cooking for fuel or not. So here you are not asking how many gas cylinders you are using in a month, or how much ton or how much ton coal you are using in a month. That is not asking. So the variables are categorical. The modalities are 0, 1 types. In this case, you cannot use PCA. PCA because the normality assumption fails here. So you cannot use PCA here. So the way out is the correspondence analysis, and most popular one among them is the multiple correspondence analysis. Okay, so here we are not going to do any dimension reduction like this. It is not, we are not going to perform this. Okay, so multiple correspondence analysis is a method of data analysis for nominal categorical data. MCA is used to detect and represent underlying structure in the data. It represents data as a points in a row dimensional in the Euclidean space. Yes, it is different space. You know, PCA is conducted in the eigenspace, eigenvalue, eigenvector, eigenspace, and it is, since it is 0, 1, so it is Euclidean space. So the space of analysis, something is like to physics. So we are not discussing this, or we will not keep it in the mind also. You know, the software are available nowadays. Without knowing whatever the space pattern, we can conduct ourselves. So MCA is a counterpart of principal component analysis for categorical data. We cannot conduct this if the data is continuous like in PCA. We cannot use MCA. For MCA, for using the MCA, you have to have all the variables are categorical. All the modalities are categorical. So it was first developed by Acceline in 2002, not much ago. Some of the features are here. I am not going to discuss it. Just keep that it is. I have conducted a multi-dimensional poverty index, and these are the weights. These are the factors. One thing we have to remember, you know, this PCA, the PCA as well as MCA has a tendency that lower values can become negative. In such a case, in case of PCA, you have to conduct the standardization. That is actual value minus minimum value divided by maximum value minus minimum value. So non-standardized index to be transformed into standardized index. And in case of MCA, what you need to do, that whatever be the minimum value, the maximum size of the minimum value, that is say minus 10, the maximum size of the minimum value to be added to all, so that the minimum value becomes 0. So that minimum value becomes 0, so that you can compare. Because some of the negative values and some of them are positive, you cannot compare them. You have to compare. If you want to compare the index values, that is the purpose we generally use. So we have to do it by using that negative and positive values. Okay, so if some of the values are negative and some of them are positive, you cannot use the comparison. You cannot compare them. So for the comparison purpose, some maximum value of the maximum negative to be added everyone, so that the minimum value becomes 0. That is the procedure of standardization in case of MCA. However, in case of PCA, the procedure of standardization is actual value minus minimum value divided by maximum value minus minimum value. Is it clear, audience?
Yes, ma'am.
Can we start the practical purpose, practical one? Are you ready for the practical? Please respond.
Yes, ma'am.
Are you Okay, so you have the data set with you. I have shared 2 data sets. You have with you, isn't it? আছে না নেই?
ডেটা সেট দেওয়া আছে।
Oh, তাহলে তো we can conduct না study.
আমি শেয়ার করে দিয়েছি।
So just use that data set. Okay, let me open the Strata file first. Then I